Hello, chemistry students. I wanted to give you this video to show you how to create electron dot diagrams for ionic compounds. In the past, we've been doing electron dot diagrams for atoms, for both metals and nonmetals, but now with the study of ionic compounds, I am going to use electron dot diagrams to show you how electrons are transferred from the metal to the nonmetal, forming oppositely charged particles, or ions, and then those two oppositely charged particles are held together by the electromagnetic force. So I want to do a couple of problems here just to show you how. Let's start with the first one where our metal is potassium and our nonmetal is fluorine. So on our page here, I'm going to use blue for our metal. Potassium is in the very first column, and therefore it has one valence electron. So my potassium atom only gets one dot. So there it is. Now my nonmetal, fluorine, is in the seventh column, close to the very edge of the periodic table on the right of the stairs. And so fluorine is going to get 7 because it has 7 valence electrons. Notice the pattern that I used in order to add the dots to fluorine. You should be following a pattern similar to that as well, because it really does make a difference. Because look at what's going to happen. Recall that our metal is going to lose all of its valence electrons in order to expose a full valence shell underneath. So potassium is going to lose its valence electron and transfer it to fluorine. Fluorine, being a nonmetal and wanting to gain enough electrons in order to have a full valence shell, really wants that one electron. So it's going to take it. And so what happens when potassium loses its electron is it becomes positive. And notice that I have no dots around my K because the dot has been transferred to fluorine. So fluorine, I'm going to draw right next to it. There are fluorine's 7 valence electrons, and there is potassium's electron, or the electron that it got from potassium. And because fluorine gained an electron, added more negative charge to it, my fluorine is now negative. And these two atoms here are now they're ions. These two ions are oppositely charged, and so they're attracted to each other by the electromagnetic force. So this is the electron dot diagram for a compound that's made between potassium and fluorine. The other thing that I just want you to notice about this ionic compound is that together it has a neutral charge. So we have one positively charged particle, that's my potassium, and I have one negatively charged particle, that's my fluorine. And when you add a +1 and a -1 together, you get 0. So an ionic compound has to have a neutral charge. Let's move over to the side where we're writing out the formula. In order to have a neutral charge, I need 1 potassium and 1 fluoride. And so my formula is simply KF. And if you want to get fancy, this is more of a nice to know thing. You can name this if you want to. In order to name ionic compounds, we name the metal, and then we name the ion of the nonmetal which in this case is fluoride. And remember, if you're changing, when you're writing out an anion's name, you just change the ending of the element's name to IDE. So that was a pretty simple one, right? Because we have just one positively charged ion and one negatively charged ion. Their charges are equal and opposite, meaning that they're both ones, but one's a negative and one's a positive. And so that was a pretty easy one. But let's come down here to a compound that's formed between magnesium and iodine, because it's going to be a little bit different. Magnesium is going to have 2 valence electrons because it's in the second column and it has 2 valence electrons. And iodine is in the very same family as fluorine, so iodine is going to have 7 valence electrons here. So iodine needs 1 more electron in order to have a full shell. So it's going to take an electron from magnesium. And now this iodine is going to be totally happy because it will now have 8 electrons in its outermost shell. But magnesium is unhappy. It still has 1 more electron to get rid of in order for it to have a full valence shell. So if we want to make a compound that is purely between magnesium and iodine, what needs to happen is I need to add another iodine. This iodine, just like its clone up here, is going to have 7 valence electrons and only needs 1 more in order to have a full valence shell. And where is that 1 more valence electron going to come from? Well, it's going to come from magnesium, of course. There. Now my magnesium atom has lost both of its electrons and it's happy because now its valence shell underneath is going to be full. My first iodine, now iodide, is happy because it will now have 8 valence electrons. And my second iodine, now iodide, is happy because it also will have 8 valence electrons. So to draw the electron dot diagram for this, I am going to put the least abundant atom in the center. So the least abundant atom here is magnesium because I have only 1 magnesium and 2 iodine. So abundance means like which one is the most common, is the least common. So my least abundant atom here is magnesium. So magnesium goes in the middle. And magnesium lost its 2 valence electrons, so it doesn't get any dots. But it does get a charge of 2+. Why 2+? Because it lost 2 negatively charged particles, so it lost 2 electrons. On either side of my magnesium, I'm going to draw my iodides. Now, my anions always keep their electrons. And there's the charge. And then I'm going to put my other one on the other side. So the least abundant atom goes in the center. And it's surrounded by the anions, or the elements that are more abundant. There. Now, let's just take a look at our charges to make sure that our compound here is neutral. Well, I have a 2+, I have a 1-, and I have another 1-. And if I were to add all of these up together, and you could even do that in your calculator if you want, I would get 0. Which means that my total charge for my compound is 0. Now, let's write out the formula. I have 1 magnesium. When I'm writing out formulas, my metal always comes first. And I have 2 iodides. My iodide, my anion, always is written to the right of the metal. So metal, non-metal. But I've got two iodines. Here's how I show it. Subscript of 2. And if I wanted to get fancy and name my compound, I name the metal, which is magnesium. And after that, I name my anion, which is iodide. And again, that's a nice to know thing, a little bit extra. All right, guys, I hope that this video helped, and good luck on your sheet, and we will talk about this more when we meet the next time. Thanks a lot. I hope you learned something.